Welcome back, folks. We are going to be looking at exploration 3 and 4 here. So we're going to be looking at Newton's second law of motion and third law of motion. This is page 55, so if you wouldn't mind going there. First thing to note, Newton's second law involves three things: force, mass, and acceleration. Write those three things down, please. And then you need to look at this here. So first diagram, the one on this side, is the same mass in both pictures, same number of boxes. However, there's only one person pushing on this side, and there are two people pushing on this side. So what's happened here to the force? So I'll let you just look at this. And again, we'll discuss this in class. Newton's second law of motion. Again, read that section right there. And then after doing that, please, again, just press the pause button and answer that question. Move on now, please, to page 58. We're going to show Newton's second law. This time we're going to use it on a graph. This is really helpful. So anytime you're doing any calculations involving Newton's second law, it explains it there. So if you don't know one of them, what are the known variables? What are the unknown? What formula do you use? And again, we'll discuss how to do this in class. And then just a little bit about friction. Moving on to page 59. The relationship we're talking about here between force, mass, and acceleration is explained here. A good way to think about it is more force, more acceleration. Less force, less acceleration. However, it asks you here for an example. So I used an example here of lifting a heavy box. What would be the effect here? What force would you need, and so on. All right. And then finally, think about this car right here. To make your race car, do you want your car to be light or heavy? And why? Page 60, we move on to Newton's third law of motion. You start with a really strange example, but it's true, which is when you're in space and you're using a wrench, the astronaut applies a force on the screw. The screw will apply a something and something force on the astronaut. So what will happen to the astronaut unless he does something? We then explain what Newton's third law is all about, which is for every action force, there's an equal and opposite reaction force. Good way of thinking about it is this swimmer who's pushing against the wall. Okay, so the swimmer's feet are pushing against the wall. That's the action force. The reaction force is that of the wall pushing against the swimmer. That force being equal and opposite to that of the swimmer. And they do a nice example here with the piñata. What's going on with the piñata? Again, I think what we'll do here is talk about this more when we're in class, but I'm going to just leave that for you to copy. And again, to understand it, let's discuss it. And finally, we can talk about Newton's second law and third law together, which is where they're going to use this example of the ball falling toward the earth and what happens when it hits the earth. And another great example of Newton's third law is when you hit your hand against the table. Again, great example of how the hand is the action force on the table and the table is the reaction force on your hand, which is equal and opposite. It's a good way to remember it. All right, I think that's it for now.